I would like to introduce you to one case example, what it means to improve farm economy and sustainability. And what is the linkage is quite case specific, and there are no average cases, but we have to look at some typical cases. And I would say that this is related much to sustainable intensification. I like this concept because it is close to the heart of economists, which is about productivity. And productivity is one way of saying competitiveness and economic viability. So we need to have a resource use efficiency so that we should be able to produce more from less. Better utilization of our inputs in agriculture is quite essential. Not only nutrients or chemicals, whatever, but also less capital costs, less labor, or better, more meaningful farm working is one resource use efficiency. But we have a challenge. We have a challenge of climate change. We have mitigation challenges, and we have already negative impacts of climate change, which are not often remembered, so that we have had many quite strange and quite difficult conditions in sowing time, in harvesting times, and in between. And the variability of weather conditions has been rather strong in Northern Europe, so that different years can be quite different in terms of growing conditions. But somehow the situation has become more difficult, so that drainage, insufficient drainage and soil compaction, for example, have been found. And it's common, not very common, but somewhat common, that some land parcels at the farm are compacted. And what is the economic sense, economic profitability to invest in soil renovation? And that, in fact, should increase resource use efficiency. So this soil renovation to reverse soil compaction is the topic here. So it's one example of how to make resources used more efficiently. And this, I think, might stimulate quite many thoughts and might be a good example, this kind of a farm economy improvement and sustainability improvement, so that some compacted soils are difficult in many respects. I don't go to all of them. But what is the clue here in this study is that in this presentation is that we have different kinds of yield gaps. We have gap 1, which is water limitations due to soil structure, poor drainage, and there's need for farm investments, which are long-term investments. Not so easy to analyze economically always. And gap number 2 might be in Finland because of inadequate climbing, because we have low pH soils or which are prone to decreasing pH, and that is causing some sort of yield gap, at least 10%. And we can have at least 20% yield gap if inadequate crop protection due to climate change. We have pests and diseases observed, never heard before, so that we have challenges here and there. Increasing intensity of rains and more difficult droughts and more difficult diseases, so that we have a reason to be worried about resource use efficiency. Okay, in this OPAL project, we have produced some farm-level economic analysis, and we have produced some sector-level economic analysis on this topic. But I would focus now on farm level results, so that I will focus on one result published almost 2 years ago, profitability of subsurface drainage and soil structure renovation at average cereals farms in southwest Finland, made together by Tuomo Purola and me. And we presented these results once, and we have been discussing these results several times with experts and stakeholders. And there are some master's theses made in Finnish, written in Finnish, and we have some blog in Finnish as well, so that we try to disseminate and discuss this issue with farmers. And I think more research like this could be needed because conditions and even different regions in Finland are different, and soil types differ. So there's no one size fits all analysis. But let's see what we have here. We have the following. What if we make soil structure renovation first year by mechanical subsoil loosening, which costs about 8 euros per hectare? We may add some wooden fibers in the soil to improve the soil structure, and on the top of that, 3 years of green manuring, so that this is more or less fallow land, but green manure with a purpose, with the long roots and more root biomass to be created. And it's a hypothesis that we first have a compacted soil with a 30% reduced yield level, and after this handling of 3 years, the average yields could be reached. Okay, we do not know if that will realize, but if we assume so, we can then variate this assumption after some results calculation. But this means that the farmer receives no market revenues during the first 3 years, and this is quite devastating for farm economy if not much compensation. And okay, maybe some subsidies, of course, can be received, because CAP pays money also for irrespective of land use. But this means that the farmer has to get the money back, lost money back, so that it's easy to not to care about compacted soil, do nothing, and just cultivate something, but don't make the investment. So that if a farmer has no money or there is no market, market demand is weak, then some farmers may accept compacted soil. But if a farmer has, for example, some of field parcels like this, maybe other field parcels are not so prone for soil compaction. We have a method where we calculate the analysis, and it's a dynamic optimization model made for 30-year time span. So that this is drainage and renovation investments are long-term investments. And we have a generic farm, typical farm with 10 field parcels and at various distances. In Finland, it's common to have various distances between field parcels. All 5 field parcels are not so close, and the average distance in Finland is a little bit less than 3 kilometers from the farm center to the field parcel. Yes, and the model is able to track the soil pH effect on yield, and fungicide use and nitrogen fertilization effect on crop yields. And monocultural land use per field parcel implies some yield penalty. So this model tries to mimic the basic mechanisms of input use response. This is the idea in the model, so that there are several responses at the same time. And what we have, the data in the beginning, I would say that we have quite high costs compared to the yields in Finland. And these prices consider also the freight costs, and these are rather low. And this study was made 3 years ago, so it is not, so the prices are not the very recent ones, but they must be average prices over several years. So these prices are prices from year 2000. So that if we have a 30-year time span, we should not use 1 year price data, but over longer time period, so that they are price expectations, what to expect, what are the real prices. And the model is validated. Of course, this kind of model requires validation. So that does it make sense? Does the model make sense? Does it produce the average yields? And yeah, because we use empirical data material and production functions and response functions, we can find that the model fairly well replicates average yields of Southwest Finland. And we use high discount factor because our reviewers were saying that we should use high discount factor, which we however test in our sensitivity analysis, that what is the impact of discount factor. But the risk aversion parameter is to be low because there's empirical evidence in Europe that risk aversion is not any huge issue in European, Northern, Western European agriculture. But this is about validation. Let's go to the results. So first, we have reference no soil compaction. And we have a typical land use in this region, so that 70% is on cereals. 70% land is used for cereals on this cereals farm. This is not an average farm, but the typical cereals farm. Yes, a nature management field is there, often at the most distant field parcels. If you look at the right-hand side column, you can see that the nature management field, which is paid some subsidy. So it's not harvested, but it's located on the most distant field parcel. So the field parcel 10 is the most far away, and parcel 1 is closest to the farm, which is quite, I would say, because sensible, because this model also accounts for logistic costs. So results if no soil compaction. So we have tested the model, of course, with the low prices, high prices, and baseline prices. And we can simulate more or less close to the average yields at the base prices. And we have lower yields if low prices and higher yields if high prices, because high prices implies more profitable use of fertilizers, liming, and fungicides. But this is how the model behaves, and there is net present value, which is an income measure here. And we have a management scenarios and cases for sensitivity analysis. And let's say that we have a compacted parcel scenario with 30% crop yield reduction on 20% of the land available at the farm. And compacted parcel scenario means that the farmer does nothing to fix this. And there's renovation scenario where farmer renovates parcels 3 and 7.
Hey, 3
yes.
minutes.
Okay. So we have found that it's reasonable to make sensitivity analysis, and we have quite a lot of results, but I present only few of them. So this is the essence, that how to get the money back. So that if we have a soil renovation scenario and compacted soil renovation scenario, we have higher net present value over 30 years. So we have about close to 3% higher NPV if a farmer can retain the yield level back to normal. And we have slightly higher yields we can get higher yields, but not so much higher yields. So that this is no economic luxury to do this, but it's profitable in this case. And why? And we can see that higher prices will imply almost 5% higher incomes on the long term, and even higher yields. And also fungicides are used more often because then it pays off to use different inputs productively. And okay, what if we have a look at the payback time? When farmer can get the money back? So that in baseline prices in 8 years, or okay, in less than 10 years. And if the prices are lower or higher, surprisingly, we have a longer payback time. But the clue here is that if the future prices are high, the farmer loses in the beginning and gets back the money in the long term, and they cancel each out, so that the payback time is not much influenced by prices. And we have cases where if the compacted soil has only little effect on yields, if only 10% reduction because of compacted soils, okay, payback time is long and profitability of renovation investments is negative. This is the message here, that if the effect on yields is small, why to invest? No reason, no economic reason. And discount rate has some effect on the economic outcome. Of course, if a farmer is very long term, so that the farmer can operate more than 50 years and is just happy and healthy, then low discount rate. But if high uncertainty about the future, then 5-6% discount rates are recommended. And the discount rate does not make any revolution for the results. Discussion points. We have found that increased production potential must have some use, so that if a farmer improves the soils, there should be a reason, so that the farmer has an idea what to produce then. If a lot of set aside or environmental set asides, then maybe this compacted soil is okay, so that a farmer doesn't need the soil so much. If not very intensive cultivation in the beginning, there is not so much point in investing in soil renovation. And it is important to avoid soil compaction later, so that we must have good crop rotations to avoid soil compaction later. And the second point is that of course, if higher future prices are expected, then it does make sense to make such investments. And long payback times imply that policy incentives might be needed, because more than 10 years is quite long for a farmer, typically, to get the money back. Conclusions, last slide. So we need reasonably priced means of sustainable intensification. And increasing crop yields is necessary for the viability of agriculture, because profitability of production has gone down. So that we must be careful what investments to make. And sometimes compacted soil should be renovated, but think twice before doing it, because the field plot must be productive, of high productive potential, and any field parcel should not be invested in soil renovation. And if we get higher yields, then what to do with the area? Maybe nature protection, biodiversity, carbon sequestration, or what? So we have possibilities here, but quite challenges. Thank you.